So we started out here, don't have it drawn like this, but we started out with angle ABC, which as you can see would be an obtuse angle. And now it has line DB going straight down the middle of the angle, cutting it directly in half. Now this is called bisecting an angle. And when this happens, of course, the original angle is split directly in two. So if these both started out with angles of 60 degrees, the original angle would be
120 degrees.
Exactly. Okay. And also another note, these two angles, being that they are bisected and are equal, are also we can also call those congruent angles. Okay, moving on. Now in this situation, we have lines AB and CD, which intersect with one another, and they create 4 total angles. And these angles, AEC, with E being the center point, and DEB, are going to be called opposite angles. These angles, like the congruent angles, these angles are actually going to be congruent because they're what are called opposite angles when what happens when two lines intersect. Can you see how these would be the same measurement?
Yeah.
Because these lines cross each other perfectly, mirror image.
Yeah, that makes sense.
Okay. Now, what if we know this is 70 degrees, then this would be
70 degrees.
And if we know that, and we also know that angles CEB and AED are also, now what is that word that I just brought up?
Congruent angles.
Yes, they are both congruent angles. Oh, I already. What would the measurement for those angles be?
110 degrees.
Both of them.
Both of them. Yep. And how did you get that? Just explain briefly.
Because a line has when two angles are intersected, both of their angles total combined comes to 180 degrees, and the full circle is 360 degrees.
Exactly. So then the rest of this angle would have to be 110 because this is a straight line here. Exactly. Okay, so now that we've got that down, just going to bring up briefly this concept, which is two angles that, two lines here, AB and QR, that no matter how long they would extend in either direction, they would never touch one another. These are called parallel lines, and we denote or mark this by, there we go, these two vertical lines here between the symbols for line AB and line QR. So these are parallel lines. Finally, we have something called a transversal. Now this is where a line intersects two parallel lines, and this will now create sets of congruent angles. So here A and D are congruent, they are opposite angles, same angle, and C and B are also congruent, equal. Now because this line intersects this other parallel line in the exact same way that it does this line, these angles here, G and F, are going to be equal or congruent to angles C and B, and similar for these two sets of angles. And I have a brief demonstration of that here. This is just another reproduction of copy of, it's a little bit floppy, of the original transversal that I had diagrammed here. You can see two parallel lines and the intersecting angle. Now, I'm going to show you what happens if we just slide this parallel line where the line intersects it down to the other parallel line. As you can see, they match up perfectly, and angle A is congruent to angle H, and G is congruent to angle B. So there's just a visual representation of how that works.